Java 3D Cube Runner. Part 3. Displaying Game Over upon cube fall or collision. This video explains how to display the message Game Over when a moving cube falls off the base or collides with one of the scattered cubes, and how to display the message in the center of the game window, even if the scene is moved by pressing an arrow key. 1. Determining where the moving cube falls off the base. There are two approaches to locating the drop-off: console logging versus mathematical calculation. In a previous video, Java 3D Cube Slide Game Part 2, console message on hit, I used the system.out.println statement. In this video, I calculate where the moving cube will fall, probably, which is easier than using the system.out.println statement. 2. Determining where the moving cube is located. In the above video, Java 3D Cube Slide Game Part 2, console message on hit, the cube moves in a straight line, so if you know how many times the space key is pressed, you can determine where the cube is located. In this video, the cube does not move in a straight line, so this method cannot be used. You need to know the exact position of the moving cube. Using Transform 3D allows us to determine the x, y, and z coordinates of the cube's local coordinate system. In my previous videos, I've used this line of code many times to move or rotate an object. By combining this code with this code, you can find the cube's exact position. TG and T3D each have an internal 2D array called a matrix for calculating coordinate transformations. The current x, y, and z coordinates of TG are extracted from the matrix within it and copied into T3D and stored in trans. You can then easily access them using trans.x, trans.y, and trans.z. 3. Displaying Game Over when the moving cube falls off or collides with another cube. I created two Text 2D objects, Text 2D and Text 2D2, and then set Game in one and Over in the other. By adding these lines of code where the moving cube falls off the edge of the base and where a collision occurs, you can display Game Over when the lines are executed. ViewTrans is the transform group that is immediately above the view platform, something like a base the view is on. Connect Text 2D objects under ViewTrans. The Text 2D objects and the view move together with ViewTrans. Source code explanation. Source code links in description. Feel free to use the source code to make your own Java 3D program. I reused the source code described in the previous video, Java 3D Cube Runner Part 2, detecting collisions of a moving cube. Keeping track of the position of the moving cube. 1. Create a Vector 3D object, trans, for keeping track of the position of the moving cube. Add this line. 2. Print the initial values of trans.x, trans.y, and trans.z to the console. Add these lines. 3. Extract the current x, y, and z coordinates of moving TG from the matrix within it, and copy them into T3D. Then, store them in trans. Add this line. 4. You can check the current x, y, and z positions of TG by printing trans.x, trans.y, and trans.z to the console. Add these lines. Creating Text 2D objects. 5. Add this line. 6. Make text 2D and text 2D to global. Add these lines. 7. Add this method. Create a local coordinate system, TG. Position TG. Scale up TG by a factor of 12.0. Create a local coordinate system, TG2. Position TG2. You can see that TG is positioned higher than TG2. Scale up TG2 by a factor of 12.0. Create text 2D objects, text 2D and text 2D2. String color. Font name. Font size. Font style. Connect text 2D to TG. Connect text 2D2 to TG2. Connect TG and TG2 to objdroot. Return objdroot. Displaying text 2D objects in the fixed position of the screen. 8. Add this line. GetViewPlatform returns the transform group that is immediately above the ViewPlatform object. It is the node that a view object connects to, something like a base the view is on. Connect text 2D objects under ViewTrans, which is by default located in the center of the screen. By doing this, the objects will move together with ViewTrans. Determining where the moving cube falls off the base. A cube with a side length of 2.0 is created here, and each cube that makes up the base is scaled up to 3 times, so the size of each color cube is 6.0. Therefore, each end of the base is 3 larger. The X position at the left edge is like this. If the moving cube is facing this direction when it falls, it will fall from this position. When the moving cube falls, it might be facing this direction, in which case it will fall from this position. If so, you can specify the drop threshold further to the left, for example, -185. If you would like to specify it more precisely, this length should be 1.4. Since the length of the diagonal of a square multiplied by cosine 45 degree equals 2.0, the length of the diagonal equals 2.0 divided by cosine 45 degree, which is 2.828. Therefore, half the length of the diagonal is 1.4. I specified the drop threshold as -184.4, -180 3 -1.4. Similarly, set the other drop thresholds like this. Displaying Game Over when the moving cube falls off. 9. Set to true if the moving cube falls off the base. Add this line. 10. Replace the process stimulus method. If the moving cube hasn't fallen off the base yet, this block of code is executed. Move the cube in the -z direction. Extract the current x, y, and z coordinates of TG and copy them into T3D. Then, store them in trans. You can check the current x, y, and z positions of moving TG by printing trans.x, trans.y, and trans.z to the console. If the moving cube extends beyond the base, it will fall off the base. Since the moving cube is rotated around the z-axis by -3.14 radians, -180 degrees, it's upside down, so it moves in this direction. C fell becomes true. Set the string game in text 2D and over in text 2D2. When these lines are executed, game and over are displayed. If CFEL is true, this block of code is not executed, and the cube stops moving, displaying game over when a collision occurs. 11. When a collision occurs, this block of code is executed. Set the string game in text 2D and over in text 2D2. Add these lines. When these lines are executed, game and over are displayed. Running the program in Eclipse. Thank you for watching my video. On my homepage, New Google Sites, I divided my how-to videos into groups so that you could find what you were looking for more easily. If you are interested in it, please visit the site. Links in description. Visit my channel to see more videos.